Okay, so this is section 9. And I don't have a topic number, I just have a title. Graphing logarithms versus exponentials. Section 9. Graphing logarithms versus exponentials. And the target, how do you graph exponential functions and logarithmic functions? What are the differences in their asymptotes? And explain transformations of logarithmic equations. All right, so I'm going to put a big old graph in this space, but other stuff's going to go around it as well. Let me show you what the final outcome is going to look like so you kind of know where you're going to need room. So I'm going to, my y-axis, I want it to go up to at least 16. Okay, I'm going to have a table, 2 different table of values. I'm going to be writing stuff as well. So the bottom of the y-axis, you don't have to go to the negatives as far, but on your positive y-axis, make sure it goes up to 16. Okay? Police. And I'm going to make a little table of values as well. Yes, it is. My first problem that we are graphing is y equals 2 raised to the x. All right? Now, we've already graphed exponential functions earlier in this section. So hopefully you remember some things about it. Can anybody tell me what the y-intercept is going to be? Do you remember? What you got? 1. Nice. Remember, exponential is y equals a times b to the x, and a is your y-intercept. So if there's nothing in a's spot, then we know that a is 1, right? It's not 0, because 0 times 2 raised to the x, everything's going to turn to a 0. So it's y-intercept is whatever a is. Do y'all remember if this is going to be a growth or a decay? Growth. How do you know? B is what? Greater than 1. And remember, if b is between 0 and 1, we can't just say less than 1 because it can't be negative. If b is between 0 and 1, not equal to 0, not equal to 1, then it's a decay, right? So we know the y-intercept is going to be on the y-axis at positive 1. We know from left to right, as x increases, the y's are going to increase, but we need to find some other ordered pairs. So we have the general idea of what it's going to look like, right? But let's find some other ordered pairs. So if x is negative 3, that would be y equals 2 raised to the negative 3. Anybody know what that's going to be? What do we do when we have a negative exponent? Well, not technically the reciprocal. Because if that had, like, say this was a fraction and there was a 4 in the bottom, you wouldn't bring the 4 to the top, right? But I know what you meant. If 2 is in the numerator, we're going to put it to the denominator, and that changes the sign of the exponent. So it would be 1/8. When x is negative 2, 2 raised to the negative 2. Well, that would be 1 over 2 squared, which is 1/4. What do you think 2 raised to the negative 1 is? 1/2. 2 raised to the 0 is 1. We already knew that. That's our y-intercept. 2 raised to the first power is 2. 2 squared is 4. 2 cubed is 8. So let me go ahead and plot those points and see if I want to find some others. So since I have the room, I'll just go ahead and find some more points. When x is 4, two to the 4th. 2 times 2 is 4. 4 times 2 is 8. Bless you. 8 times 2 is 16. So when x is 4, y is 16. What about if x was negative 4? What would y be? 1/16, right? How about if x is negative 5? Well, 2 to the 5th is 32. So wouldn't that be 1 over 32? Could x be 0? 2 to the 0 power? We already did that. I didn't mean to say that. I was thinking of my y. What if x was 10, negative 10? 2 to the negative 10. 2 raised up to the negative 10 is 0.0009. What if it was negative 20? 2 raised up to the negative 20 is 0.000009. Very nice. What if it was negative 100? 2 raised up to the negative 100. This is telling me to move my decimal 31 places to the left. So that's like 0.000000000 whatever 7, right? What if it was negative or raised up to 1,000? 2 raised up to the negative 1,000. It's saying 0. Your x value or your y value is never going to be 0. It's going to keep getting closer and closer and closer and closer and closer, but it's never going to touch 0 or cross 0. Okay? So do y'all remember what that line is called when a graph approaches it, but it does not intersect it or cross it? Asymptote. So actually the x-axis is my asymptote, and it is a horizontal asymptote. Does anybody know what the equation of that horizontal asymptote would be? Y equals 0, because it's a vertical line. So vertical is always y equals, right? Wherever it crosses the y-axis, and it crosses the y-axis at 0. So when we graph exponentials, you're going to have an asymptote. It may not be at y equals 0. That asymptote can move up or down. But this is just a basic exponential function. We can tell by the graph that it is a growth because from left to right, as my x's increase, my y's increase. We can also tell in the table of values, as my x's are increasing, my y values are increasing. And then we also knew because b was greater than 1, right? Okay, so y equals 2 raised to the x is an exponential growth. And we haven't talked about domain and range in a while, which we are today. Domain. What is the domain for this exponential function? All real numbers. Is the range also going to be all real numbers? What's the range going to be? Y is greater than 0. Very good. All right, so we have already learned that the inverse of an exponential function is a what? That's what we've been working on. Logarithmic function. So we are going to switch x and y, make it a logarithm, and rewrite it in logarithmic form, graph that, and see what it looks like compared to what the exponential looks like. Okay? So that's what my other table of values is going to be. So now, graph the inverse of y equals 2 raised to the x, which is x equal 2 raised to the y. This is a logarithm. So in logarithmic form, it's written log base 2 of x equals y. I'm going to make another table of values. Alright, so negative 2. If x is negative 2, that would be log base 2 of negative 2 equals y. Could we do change of base to evaluate that? Yeah. Tell me what you get. Y'all have calculators? What you get? Anyone? You got error. Huh. So 2 negative log error. Why do you think it's doing that? What's negative? Can we take the log of a negative? No. Remember, the base has to be greater than 0, and what you're taking the logarithm of has to be greater than 0. So this graph is not going to have an x value of negative 2. It's not applicable. Will it have an x value of negative 1? Will it have an x value of 0?
No.
What'd I just say? Has to be greater than 0, right? Can't be 0 either. All right, so, well, there goes those 3 points. So let's do 1. So log base 2 of 1 equals y. 2 log divided by 1 log, no, I did that backwards. 1 log divided by 2 log equals 0. So when x is 1, y is 0. So notice our other graph had an x-intercept, right? This graph has a y-intercept. Okay, 2. What's log base 2 of 2 going to give me? 1. So when x is 2, y is 1. Let's try 3. Log base 2 of 3. 3 log divided by 2 log is approximately, we'll go with 1.6. How about 4? Log base 2 of 4. 2? Correct. How about, let's go 1, 2, 3, 4, 5, 6, 7. I'll go to 8. Log base 2 of 8. 3? I didn't do that right. 8 log divided by 2 log equals 3, as you said. Okay, well, I know that x has to be greater than 0, and I'm pretty sure this graph doesn't just start from this point, but it has to be greater than 0. Well, couldn't it be like 1/10, or 2/10, or 3/10, or 4/10, or any number between 0 and 1? Yeah? Okay, I'm going to try, let's see, I will plug in 1/10. When x is 1/10. So 1/10 log divided by 2 log is approximately negative 3.3. How about 1/100th? So 0.01. I get negative 6.6. So we know the graph cannot have an x value of 0 or be less than that. So what do you think is happening? What is this approaching over here? An asymptote, right? So this time a logarithm has a vertical asymptote where an exponential has a horizontal asymptote, okay? So whenever you graph exponential, you know it's going to have a horizontal asymptote. Where it is depends on the problem. Whenever you graph a logarithm, you know it's going to have a vertical asymptote. That asymptote could shift left or right, but you're always going to have a vertical asymptote. It's hard to see. And what would be the equation of this vertical asymptote? x equals 0. Oh, sorry. I'm going to write over it in words. It didn't show up well. It says vertical asymptote at x equals 0. Negative 6.6. So the difference is, when you have a logarithm, you don't call it a growth or a decay. That's only for exponentials. Okay, it doesn't have a special name like that. We know exponentials has horizontal asymptote. Logarithms have vertical. We know exponentials have x-intercepts, where logarithms have y-intercepts. I said that backwards. Exponentials have y-intercepts, where verticals have x-intercepts. It could also cross the y-axis too. If the asymptote was shifted to the left, then it could also cross the y-axis. Okay, but it's definitely going to cross the x-axis. And what is the domain of the exponential? All real numbers. Where with, no, it's not. X is greater than 0. Where exponential, it was all real numbers. For domain, x is greater than 0 in this case. And what's the range? All real numbers. Where exponential, the domain was all real numbers. And logarithmic, the range is all real numbers. Yes, they're inverses of each other, right? Everything's flipped around. That's not appropriate math term, by the way. They're all inverses. There's also one thing to note. What do you notice about the graph of the exponential compared to the graph of the logarithm? Anybody notice what can give me like a math word that would describe them comparatively?
Oh,
They're what? They're a reflection, right? Yeah. So if they reflect, there has to be an axis of symmetry, am I right? Yes. And that axis of symmetry, x equals y, or I always say y equals x, but same thing, right? Which would have a y-intercept of 0 and a slope of positive 1. Here we go. Perfect. So when you have your assignment today, you're going to have to graph 3 just logarithms, okay? Because we've already had a whole lesson on exponential, but I wanted you to see how they compare to each other. So we also have one other page to write just about how the transformations of logarithms, how they shift left, right, up, down. If there's stretch compression, I just want you to have the rules to that so that you know what the reflection or the transformations are. Yes.
You said the work paper you did is only
Just logarithms. Yeah. Oh, also wanted to point out, since these two are inverses, then the table of values, we could have just taken the table of values for exponential and just switched the x and the y and gotten the table of values for logarithms instead of doing all that work, couldn't we? Yes.
Oh, yeah.
However, I didn't want to do that because a lot of times you're just going to have to graph a logarithm. You won't have the exponential beforehand in that graph already there. So I wanted you to know, if you didn't, how to graph it. But like if we look up here, 0, 1. So on the other graph, we should have 1, 0. 1, 0. We do. 2, 4. On the other graph, we should have 4, 2. We did. What else do we have? We didn't pick everything exactly the same. So, but if we wanted to, we could have just taken this table and flipped all the x's and the y's and gotten a table for the logarithm when we wouldn't have had to do any of that work. You know what I mean? Jelly bean. All right, you don't need graph paper for this next page. You can write on graph paper if you want, but you don't need it. This is called logarithm transformations. Or you could do this on the back of your graph paper as well if you would prefer. It doesn't matter to me. All right, so the parent function of a logarithm. Remember, parent function is the most basic. Is y equals log base b of x. Or you could write it as log base b of x equals y. Those are just the most basic. And remember, b must be greater than 0, b cannot equal 1, and x must be greater than 0. So if anything changes to that parent function, if you're adding something on or multiplying or subtracting or dividing, it's going to transform that parent function, okay? It might change that asymptote. It might shift it left, it might shift it right. It might open wider or open more narrow. It might reflect across that asymptote. So I'm going to show you how to tell if there's any, it may not be any transformation. Okay, so if we had y equals a log base b of x, that means we have a number that's being multiplied by the logarithm. That number is going to tell us if the logarithm's a stretch, a compression, or a reflection. Or it could be like a stretch and a reflection, or a compression and a reflection. Can't be a stretch and compression. Remember, y'all learned in geometry, compression kind of like opens up the graph wider than the parent function, whereas stretch makes it more narrow. And reflection, logarithms are always on the right side of the asymptote. Unless it's a reflection, then it would be on the left side. Okay? A is going to tell us. So, your logarithm is a stretch if the absolute value of a is greater than 1. So a could be negative 2, but its absolute value is positive 2, right? 2 is greater than 1, that would be a stretch. It is a compression if the absolute value of a is between 0 and 1. So the way I write that is 0 is less than the absolute value of a is less than 1. The way you say that, the absolute value of a is between 0 and 1. So like say it was 1/4 or negative 1/4. It is a reflection if a is less than 0. Not the absolute value of a, but a. So if it's negative, your logarithm graph is going to be on the left side of the asymptote instead of the right side. Now your graph could also shift up or down, left or right. And the way you tell that, we have y equals log base b of open parentheses x minus h close parentheses plus k. Now one really important thing to note, that h tells you where your asymptote's going to be. But also you have to realize that in this format, it's subtracting h. So if h was 4, it's going to look like negative 4 when you plug it in, right? So you have to remember, if this says log base 2 of x minus 4. That means your vertical asymptote is going to be at x equals positive 4. So if this was x plus 2, your vertical asymptote is going to be at x equals negative 2. Okay? This is a k. So h tells you where the vertical asymptote will be. H also tells you if it's going to shift left or right, which is also opposite of what it seems, okay? If H is negative, whoops, I didn't mean to put a 1 there. If H is negative, seems like it would shift left because you go to negatives when you go left. But remember, the sign's opposite. So actually, when it's negative, you shift right. So if that was x minus 5, you would shift to the right 5 units. And then if it's positive, you shift left. And then K tells you whether you shift up or down. If K is negative, you shift down. And if K is positive, you shift up. Coolio? All right, so we're just going to do a quick graph. We are going to graph y equals log base 3 of, open parentheses, x minus 4. Now, is that going to be on the left side or the right side of the asymptote? On the right, because it's not a reflection, right? It's not being multiplied by anything. So if it was multiplied by a negative number, we would know that it would be on the left side because it's a reflection. And it's not a stretch or a compression because there's no a there either. It also does not shift up or down because there's no number out here being added or subtracted. What does it do? It shifts to the right 4 units. And where's the asymptote going to be? At positive 4, right? Because you got to remember this, change the sign. So we're just going to do quick little graph. So that's where the asymptote's going to be. And you would know that anyway because say you chose to plug in negative 2. Negative 2 minus 4 is negative 6. Can't have it take the log of a negative, right? If you chose 0, 0 minus 4 is going to give you a negative. If you chose 1, 1 minus 4 is negative 3, another negative. 2, 2 minus 4 is negative 2, negative, right? If you choose 4, 4 minus 4 is 0. We can't take the log of 0, right? So that would help you know that it's not going to be on the left side, even if you weren't sure. So let's just find a few other ordered points. I know basically what it's supposed to look like. Let's just find some ordered pairs because on your assignment today, you're going to have to show me your table of values and your math. Okay? So let's choose 5 to start. So that would be 5 minus 4 is 1. So 1 log divided by 3 log, right? And we get 0. Let me try 6. 6 minus 4 is 2. So 2 log divided by 3 log. 0.6. No, I did something wrong. Or maybe I didn't. No, I didn't. Seven minus 4 is 3. Log of 3 divided by log of 3, we know that's going to be 1. Eight minus 4 is 4. 4 log divided by 3 log. 1.26. So we can tell it's going to go in this direction, right? But is that what my actual full graph looks like? No. Is it going to go back to this point and then turn upwards? No. Logarithms don't do that. We know it's going to come down to the asymptote and it's going to follow it down, right? So you could find ordered pairs between 4 and 5, like 4.1, 4.2, 4.3, 4.4, whatever. But you know it's going to come up to that asymptote and follow it down. You know what I mean? You know what I mean? Awesome. Anybody have any questions? Nope, we're all good? All right, I'm going to pause this video and then I will leave this up in case you're not finished.